Hello and welcome guys. So in the last video we have completed our model evaluation and also we have saved our model and we have done our accuracy visualization on training set and validation set. So in this video we are going to perform our model evaluation on some other metrics. We are going to calculate the precision, recall and confusion metrics of our deep learning model. So if you're new to this video then please watch this playlist from beginning. So let's get started. And here I am giving markdown as some other metrics for model evaluation. And for that I need class also. So I want to record my class name, entire class. So I am writing here class name is equal to validation. I am using this validation set variable. I am using. I need this 38 class name. So I am writing here validation set dot class underscore names. And if I print here class name, then you will see this is a list of the class which are used in this data set. Okay, so this is the entire 38 classes. Okay, so we are going to use this class name when we are going to calculate the precision, recall and confusion metrics. Then we need this class name to show that okay, so this is the class name for this apple's cap. We have this much of precision and this much of recall. Okay, so something like that we are going to perform. That's why we need this class name. So now I need test set. So if you go in our data set, then you will see here we have train, valid and test folder. But if I go inside this train, then you will see this 38 folder containing images of each class. Similarly, we have this validation folder, but if you go in this test folder, then you will see that these are some random images of the classes. We don't have here like the directory like this 38 directories, and inside this we have separate image for each class. So we can't use this test set right now because we don't have images of each class. If you see, so we are not going to use this as a test set. So what I am going to do, I am going to use this validation set as our test set. We have to give some new images to our model to evaluate our model performance. So that's why we can use either validation set or test set, but here our test set is not properly arranged. So I'm going to use validation set because in validation set we have all 38 classes of images. Okay, that's why I'm going to use this validation set as test set. For that, let me define one variable. Test set is equal to, what I am going to do here, I am going to use this same thing. So I will copy this entire thing from here and I will paste it here. So if you see, I am asking to my keras that load whatever image you have from this directory valid, and here I will do some modification because at the time of training, if you see, at the time of training I am using here shuffle is equal to true. So I am saying that shuffle the entire training example and feed to the neural network so that neural network is not biased to learn only one specific class of that data set. Okay, so that neural network can understand all the classes of the data set. So here I have put it here shuffle is equal to true, but here what I am going to do, here I am going to put it as false. So if I put here shuffle is equal to false, you go inside this validation set, this entire thing will be passed sequentially. Like first it will pass this first class, then black rod, then cedar apple rust, then healthy, then blueberry healthy. So in sequential fashion it will pass. And if I put shuffle is equal to true, then it will randomly choose either this first, then again grab healthy. It will randomly choose anything. Okay, because we have done there shuffle is equal to true. But here I am doing shuffle is equal to false, so that I am saying that pass it sequentially from top to bottom. Okay, from first class to 38 class of the data set. Okay, so that's why I am putting here shuffle is equal to false and rest of the thing will be same. So if I see here, then you will see it's giving that 17,572 files found. And now what I will do, I will perform my prediction. So let's give here ypred. So in ypred, what I am going to do, I am writing model.predict and I am passing this test set. If I print here ypred, then it will do a prediction on all the 550 batches. Okay, so we got our prediction if you see here. And if I do here pred dot shape. Okay, so it's giving here that 17,572 cross 38. It's a matrix of shape this much. What is the meaning of this? It's saying that for each file, it's giving probability of all 38 class. We have 38 class. So when I am performing here model.predict, it's giving me probability of all the 38 class for each images. 0.91 is the probability of that it belongs to class 1. This is the shape of this ypred which we are getting when we are performing here model.predict. So this is shape of ypred, and for each image it's giving 38 probabilities. And now what is our task? Our task is to select the maximum probability class. Okay, that's our prediction. That's what our aim is here. Okay, so for predicted categories, let me define one variable here. Predicted categories is equal to df dot argmax. I am using argmax. What it will do, I will tell you. So inside this, write here ypred and give here axis is equal to 1. So by applying this function tf.argmax, what it will do, it will go inside this ypred and it will extract the maximum value from this, and it will return the index of that maximum value. And here I am writing axis is equal to 1 means that I am saying that return the index in column wise fashion. X is equal to 1 means vertically count the maximum value like this, and return the maximum value from this and return its index. If I pass here x is equal to 0, then it will perform this operation in row wise fashion. But here we want this operation in column wise fashion, because we are interested in extracting the maximum probability of the class out of this 38 class. Okay, that's why we have written here x is equal to 1 and I am passing this ypred. Okay, so when I run this, then if I go here, then you will see this is what we are getting here. So this shows that it model is saying that it belongs to class 0, and we are also passing this from here to last. So if you see, initially we are getting 0 0 and at last we are getting 37. So our model is giving good result on this. Now we got our predicted categories. So this is our predicted categories, and we need true categories, so that later we are going to calculate our precision recall by considering our predicted categories and true categories. Okay, so we have here our predicted categories. Now we are interested in our true categories. That is, for each 17,572 files, we are interested in what is the category of this. So what I will do, let me define one variable true category, and inside this what I will do, I will use tf.concat and I will simply iterate over my test set. This is my test set. I will iterate over my test set. So to iterate over our test set, I have already showed you how we can iterate over test set. Here if you go for training set, we have already iterated that for x, y in training set, and if I am returning here x and y, then you will see that this is my x, which is my training example. You will see this is my y and this is all my x. Okay, so in training set we have x as training example, that is value of each pixel, images in the form of matrix, and y is our label. Okay, so same we are going to do here also. So here I need only y, because we have our predicted categories. Now I need our true categories, so that I can compare and calculate our precision and recall. Okay, so what I will do here, I will define here one list here, and I will say inside this that I am interested in y. This is a list comprehension technique, and I am iterating over for x comma y in test set. Okay, and here I will write x is equal to 0 means I want to concat all the y's of my test set in row wise fashion. Okay, that's why I have written here x is equal to 0. If I write here x is equal to 1, then it will concat in column wise fashion like this. I have already explained you what is the meaning of x is equal to 1 and what is the meaning of x is equal to 0. So x is equal to 1 means we are interested in performing operation in column wise fashion, vertical operation we want to perform, and here horizontally whatever we have we want to perform in row wise fashion. So that's why I am writing here as x is equal to 0. That is enough for this. And if I print here true categories, so if I print this, it's giving me like this. It's giving in the form of one hot encoding. Like for this, for first it's saying that it's 1. Okay, so it belongs to class 1, and rest of the all 37 classes is 0. And same for this last three training example. For this last three training example, all this last value is 1, that is its 37th index is 1. So it's saying that this belongs to 38th class, and all first 37th value are 0. So it belongs to 38th class. Okay, so this is the value which is showing that the training example which belongs to that class, that part is 1, and rest of all the 37 remaining part is 0. So this is in the form of one hot encoded form, but we want in like this. We want something like for each file it shows one class, but here if you see the shape of this matrix is different. It's 17,572 cross 38. So we have to make like this. So what I will do here also we will perform the same thing whatever we have done here. If you see, when we have calculated here ypred, then also we are getting something like this. So this is the same thing which we are getting here. So we have written here tf.argmax, and we have extracted the maximum value from that entire column. We have 38 columns, so from all 38 column we are extracting the maximum value from it. So same we are going to do here also. Here if you see, the maximum value is 1 and rest of all the values are 0. What I will do here, I will copy this entire thing here and I will paste here, and I will write here as y true and tf.argmax. Here I will pass this true category here, true category, and x is equal to 1. I am saying out of this 38 column I am extracting the maximum value from it, and I am returning the index of that one. Okay, so that I want to make it like this. Okay, so if I run this and show you, you will see here I am getting the same thing like this. So our y true is ready and our predicted categories are also ready. Now we can calculate our precision recall. So to calculate our precision recall, first let me show you what is precision recall. So if you go and search on Google precision and recall in machine learning, and you will see this definition that precision measures the percentage of prediction made by the model that are correct. Recall measures the percentage of relevant data point that were correctly identified by the model. So if I show you the example of this thing, then you will understand more better. This example is good. So here we have two level, positive level and negative level. In our case, we have 38 levels. Okay. So what is the meaning of this? This is a confusion matrix. So it's saying that model is predicting that it is positive and real level is also saying that it is positive, which means that model is saying that it is positive and it is actually positive. That is our true positive. And what is this negative level? Model is saying that it is positive, but it is actually not positive, it is negative. So for that we will say that it is false positive. According to model, it is positive, but it is false. That's why it is false positive. And for this part, false negative, model is saying that it is negative. That's why it is negative. And but it is not true. It is false. This value is not true. That's why it is false negative. And for this part, model is saying that it is negative, but it is actually negative. So this is true. That's why it is true negative. So this is the meaning of this thing. How we can calculate the precision? A fraction of true positive prediction out of total positive prediction done by model is your precision. And what is recall? Recall is the fraction of true positive prediction out of total positive level exist in your data set is your recall. So recall is fraction of true positive level which is being predicted by the model, true positive thing, that is true positive level which is predicted by the model, that fraction out of total positive level exist in your data set is your recall. Okay, now I think you have understand what is the meaning of precision and recall. So this image is good for us. We can keep this image there also. This is what I'm explaining there. So this is the meaning of precision and recall. And to calculate accuracy, we will count this true positive and true negative upon total. Okay, all green upon entire matrix. Okay, this is your accuracy. This is a formula of precision recall. And to perform this precision recall here, and we can use scikit learn. So I am writing here from sklearn, from sklearn.matrix import. I am importing here classification report. This class I am going to use to calculate my precision recall. So if I show you the documentation of this thing, sklearn.matrix. So this thing I want, sklearn.matrix.classification report. If I go inside this, they have provided a very good documentation for this thing. So if you see, this classification report will take true label and predicted label. Okay, true category and predicted categories. Also they are taking as label. You can give your label if you want, array of like of shape and labels. You can define your label also. And target name is actually optional display matching labels. It is actually your class name. Okay, so you can pass this thing also there. So this is very good documentation. You can read here if you are interested in reading. We have imported this thing. Now what I am going to do, I am passing here classification report, and inside this, if you go in the documentation part, it's passing the true label. Okay, so we have here y true as our true label. So I will pass here y true, and second thing is our predicted label. So here our predicted label is our predicted categories, this thing which we have calculated for all 17,572 files. We have calculated our predicted categories. So we have passed here two categories, and now we will pass our predicted categories here. Okay, and third thing, I will pass this thing, this target name I will pass, because I want to display my all class name. So I will write here target name is equal to class name. Okay, that's all I will pass, and I will print this entire thing. So let's print this. If I am printing this, then it's showing the precision recall and F1 score and support for all these classes, all these 38 classes. And at last it's also calculating accuracy and macro average, weighted average, these things also it's calculating. So it's giving me a very good report, so that by seeing this we can identify that how much percentage of our model is predicting to what class. Okay, if you see, precision of this apple scab is this much and recall is this much. So by seeing this we can came up to the conclusion that okay, so for this class this much is the precision and this much is the recall. That is so that you can understand that if there is some biasness in your model or in your data set, then also that thing can also be detected by calculating this precision recall here. Okay, and at last they are also calculating the accuracy on this test set which we are using here. Here for test set I am using validation set. You can use, if you have your test set, and you can use that test set also to calculate your precision recall and F1 score. What is this F1 score? F1 score is the harmonic mean of this precision and recall value. If you go to see the formula of F1 score formula, then you will see that this is the formula of 2 times precision into recall upon precision plus recall. It's actually the harmonic mean of the precision and recall. So this is a formula of precision recall which they are using to calculate the F1 score. Okay, so we got our classification report here. So that's all for this video. In next video we will calculate our confusion matrix, and also we will perform the confusion matrix visualization using Seaborn library of Python. So that's all for this video. We will meet in next video.